For those of you who don't know me, I've been programming for a little bit over 20 years now, working most of that time on Advanced Installer, basically improving the virtualization and packaging capabilities of Windows applications. And I've done some open source work as well. Some of you might know Clang Power Tools. Right from the start, I have to preface this with this being my C++ universe. So it's a very personal experience about the things I've learned teaching C++ in uni, and the things I've learned in sharing my experiences with friends of mine in academia, and the things I learned from students and interns and young developers I mentored. And this might well be different from your experience, and I'm actually very interested to hear your opinions and your take on various topics that I'm going to cover. So it's definitely a personal take, or my opinions and my scars with regards to teaching C++, especially to freshmen and sophomore. So my experience is closely related to my alma mater, University of Craiova, where I was a student more than 20 years ago, and where I'm a visiting professor. So especially in the computer engineering department of my alma mater, where I regularly go and teach invited workshops every year for the past 6 or 7 years now. So I'm a regular guest at the computing engineering department. I give invited lectures and workshops on various topics, STL, algorithms, optimization techniques, programming principles in general. I've been doing this for a while now, and I've collaborated with my friends in academia. We coached teams for student competitions, and we worked with very, very bright young programmers there. In June, July every year, again in collaboration with some of my friends, it's a very rewarding experience for me to organize and teach a free workshop, Open for Tech Summer School for Software. It's aimed at college and high school students, so it's open for everyone, but mainly college and high school students attend each summer. We just ended another successful, albeit online version of Open for Tech. This July, we wrapped things up, and I had a blast teaching a workshop on hashing algorithms and hashing containers this year. The topics I've covered over the years in my lectures and workshops, again, this strongly influences my experiences and the reactions and the feedback I got doing this. I taught programming techniques for freshmen, algorithms and data structures, particularly graph and trees, node-based data structures. I taught pure C++, both pre-17 and C17 and 20 C++. So I've been doing this for a few years now, and I got a chance to teach both the old ways and the new. I did a little bit of functional programming. I did a workshop using Haskell, like a hybrid, using Haskell and functional style C++. I'll talk about a little bit about this later on. So I did this experiment as well to see how it fares with relation to the other ways I went about teaching algorithms. And this year I did a workshop on hashing algorithms and containers. So generally, student expectations in year one is that they hear that software is eating the world and they want to be a part of it. And they're very enthusiastic, and they may have some programming knowledge from high school. Maybe some of them have, not all of them. But certainly most of them don't have any real experience with C++. They've heard of it, but they don't have any real experience writing programs in C++. And C++ has been a staple diet in most universities that I know of for more than 20 years, I think. So the question at hand is C++ a good starting tool for learning programming in general? Is it a fit language for CS1? How successful are we as teachers in imparting good programming techniques? And is C++ a good first encounter with programming in general for people starting out? And as you might imagine, even with modern, as we like to call it for more than 10 years now, modern, postmodern, however you like to call it now, even with modern C++, for most students, I would say the first encounter with C++ is a little bit violent. And I'll show some of the things I've seen and some of the takes I've seen from students in trying to navigate this uncharted territory with C++ as a driving tool. So the question at hand is C++ good as a first language, really, for CS1? And I would point you to a very good presentation by Patrice Ciura from CPPCon 2019. Patrice, as opposed to myself, is actually a long-time teacher, a very experienced teacher, and has been teaching both college and uni, and has been doing it for many years now using C++. So he has very good tips and very strong opinions with regards to different techniques. And for him, the verdict is quite clear that C++ is fit as a first language. And he has very nice examples and shares the experience he gained over the years in teaching people. And he also does workshops at conferences. He regularly does workshops at CPPCon as well. And you can see that many people sign up for his workshops. So he clearly knows what he's doing there. So I do encourage you to save this link for later and watch this talk by Patrice if you haven't seen it already. So coming back, things I'm hearing from people in the industry, from people in academia, common themes that keep popping up with regards to using C++ as a teaching tool. There's lots of room for us to make C++ more teachable and improve the quality of C++ teaching in uni. I think everyone agrees on that. But here's where the catch lies. So long as we're not talking about CS1. So many people think that C++ has a place and it's important to be something that is used in teaching and in learning, in programming in universities. But some people are reluctant to say that this is fit for the first encounter. And the argument is that first students have to get over the hurdle of being algorithmic thinkers, and then we can give them a language that has these sharp edges. So I'm not exactly sure. I'm not going to give away the ending here. Of course, there are alternatives, and I would like to hear about maybe alternative routes there. I don't know if this is the right community, being a C++ meetup, but I would be interested to hear different opinions. For example, people using TypeScript or JavaScript or Python as an alternative first language for freshmen. So I did some experimenting. So I've been doing teaching the traditional way for a few years now, but I did, I think 3 or 4 years ago, I did an experiment where I tried to teach functional style programming, both with Haskell and teach about higher order functions, and even teach C++ in a functional way, to see if the problem lies with the low-level mechanics of the language and memory management and the imperative style of dealing with variables and state, or the problem is in the composition part, or the algorithms, or the standard library. And I tried to weigh down to see which route went better. So I did a course, Career on Functional Programming. There, a big help in this regard was the material in Ivan's book, their Functional Programming C++. I highly recommend this book. If you had a chance to read it, it's well worth your time. It's something different. I'm sure even experienced programmers will learn something new from this book, so I do encourage you to read it. So I did experiments with C++ 20 ranges before they were C++ 20. So I did experiments in trying to teach algorithms using range-based libraries, and that turned out to be more successful than I expected. So students actually build up an intuition in terms of composition and projections and piping operations. So it turned out better than I expected there. But if I in hindsight, if I go back and analyze, I think the most effective approach, at least in my case, was still the traditional way of learning about STL algorithms and data structures, and learning about modern post C++ 14 features in the traditional way, rather than taking the functional route. Maybe because some of the students had already been corrupted by the imperative way of thinking about organizing programs in a sequential way, and thinking in terms of instructions or step-by-step instructions, rather than composing higher order concepts and thinking in terms of function as first class objects to be passed around. And definitely I found that lazy evaluation is a thing that doesn't sit well with many students. So I found that the traditional approach in teaching C++ and STL fared better, a little better than the functional route I tried to take. So some of the sharp edges students encounter around language, both language and library. So if you think about very simple concepts, students immediately run into very tricky situations immediately. As soon as they go beyond toy examples, standard textbook examples, as soon as they start actually doing meaningful stuff, meaningful programs, as I try to push them in that direction, they immediately run into compilation errors and semantic issues and undefined behavior even. So if we think about special member functions and the whole mess around understanding when special member functions should or shouldn't be declared, or using the default implementation and so on. So some of the rules are very confusing for many students in this regard. And I'm sure we're going to hear more about this in Peter Sommerlad's presentation of 2 weeks from now, if I'm not mistaken. So I'll leave that for Peter to discuss, because he has strong opinions around special member functions and his rule of Destemova. Getting started with a project, because students are encouraged to work on long-term projects, not just writing up functions. So getting started with projects, again, a bit harder for students. They don't want to reinvent the wheel. They want to reuse existing components and take on some dependencies. Again, this is not a place where C++ shines. As a community, we haven't agreed on a unified package management or a unified repository for packages. So again, they have to scramble and think about taking on dependencies and what that implies for their projects and for their build. Some examples that perplex students from right from the start. They have to deal with strings. So I've taken this example from Victor and Jason Turner. So again, a simple act of constructing a string or constructing a substring there, it can be very perplexing. And I think it all boils down to the fact that standard string has 11 constructors, and there are no compiler diagnostics or warnings to actually help you navigate this mess if you're not hitting the right overload or the constructor that you actually meant to hit there. And if you're talking about C++ 17 and types, new vocabulary types like string view and span in C++ 20, it turns out it's actually worse for beginners in my experience, because by design, it's easy to convert a string to a string view and a vector or array to a standard span. So dealing with dangling references there, it's almost a default behavior. Things like reference semantics and lifetime extension are difficult concepts to explain, and they turn out to be surprising for people learning right away. Even the basic idea of string view not being really a reference type or a value type, being this kind of borrow type that acts strange. It doesn't behave like a regular reference in extending the lifetime of a temporary. Turns out to be very surprising for many people learning about it and wrongly using it. There are CPP core guidelines, of course. That's always our answer, but nobody reads the docs, honestly. We're talking about students here, right? But we have tools, and we'd like to think we don't read the docs because we have great tools to rely on, and we do. Some of them are good. ClankTidy has a specific check for the scenario of a dangling handle like string view. So there is a specific check for this. And there are flags to diagnose this kind of dangling reference starting with Clang 10 already. There are plenty of ClankTidy specific checks related to strings, so good, decent coverage there. But I don't think people learning to program get into the habit of actually relying on tools beyond the compiler and the standard libraries. So we have to constantly encourage them to explore additional tools and regularly use them. Because the difference here being that the compiler and the library, you kind of have to use them to produce running programs from what you write, as opposed to static analysis tools and linters and everything, which are add-ons or an afterthought or something that people learning consider a hurdle to use. And we're not talking about people setting up CI/CD systems here to learn. So relying on additional tools, it's something that we cannot honestly expect the students to do. We can encourage them, but Again, first encounter here with, as soon as we talk about ordered collections and algorithms that work on ordered collections, we talk about sorting, and more complications come here from new concepts that pop up with regards to sorting things. We have to deal with named requirements and ranges, and we have to talk about binary predicates and what that means and why is this important. The compare named requirement, why is it relevant, and what it takes for type to be able to participate in a collection that can be sorted without undefined behavior. So what kind of ordering relationship is needed for the elements of the collection in order for the standard sort algorithm to actually work. And as soon as we try to drill in and see, their intuition tends to gravitate towards partial ordering, and that's clearly wrong. And I have to show them examples where this is not holding up. And for example, I try to encourage them to find a good sorting predicate for a 2D point, and they immediately go for comparing with a logical and both parts of the structure. And again, I have to show them by example why this is wrong, and it's not a good compare predicate for sorting 2D points. The visual aspect, I think, is very important in showing them where situations are undecidable, where two elements are clearly ordered, and situations where given the predicate used, we cannot decide if those elements are ordered or not. So again, they have to build up intuition for what equivalence is and equivalence classes. And I try to visualize these things so that they go beyond axioms of partial ordering and strict weak ordering to actually understand why the predicate that they wrote is not fit for this, and how we need to strengthen this relationship, this requirement, and add the transitivity of equivalence now that they've seen what equivalence means for a given predicate. And again, the formalism behind it. And then we gradually move together towards a strict total ordering, strict weak ordering, and see elements that are totally ordered by less than, and how it fits in with the initial example that we started, and if it checks out in actual examples, so that they gain confidence in the predicate they've built. And almost all the time, every year, I do this. The very next thing that pops up as an example coming from them is the distance from the origin in a Cartesian plane as a suitable compare predicate, which checks out with regards to the axioms and the requirements of the STL there. But it takes a lot of work to actually lead students to a discussion and to think about comparing a structure with parts in comparing them by parts, comparing the first part, in this case, the x coordinate, and in case of equivalence with regards to the first part, compared by the second part. So comparing this idea of comparing by parts, it's not something that really comes right away for them, and it takes some hand-holding and explanations and many examples to lead them to this path, and talk about lexicographic order and lexicographic compare. So I always find these issues problematic when teaching sorting and teaching strict weak ordering and STL requirements. And I see them really understand after a long discussion on this topic, but it's not something that comes natural or something that is immediately intuitive. So I think we have to do a better job here. And I'm not exactly sure that C++20 concepts will help in this regard, because actually checking at the interface level for the algorithm that a particular named requirement is not met, it's certainly a flag. So it's no longer a runtime surprise. It's certainly a flag they see when compiling that something is wrong. But it takes a while to understand why something they wrote, predicate they've built, is not appropriate. So you've exchanged undefined behavior or a bug at a runtime with a compiler, which is great, but it still takes quite a while to build intuition on figuring out what the right answer is. So it's tiresome, but I think it's worth it. Going beyond the traditional classes, 2020 and this year as well has been challenging on a whole different level. I continue doing these guest lectures in the online format, and as many trainers, friends of mine shared, this comes with new challenges. So by the way, this is the exact same example I walked you through. I think you can see the puzzled face on on this student. Okay. This was the workshop from this year. So I think one of the major challenges in online training and online classes is the interaction. The fact that you don't have a rapport with the audience. You have the sensitive issue of the camera on, and you don't have any feedback, direct feedback to see on the students' faces if an explanation really reaches them, or if they might have some doubts or some questions or something, because they don't always reach out for the microphone or the chat to ask a question or interrupt to settle something that it was not clear for them. So I always have to scan the little rectangles to see their faces, to see if they're still with me, or if maybe I have lost some of them at some point. So there's a sensitive issue and a recurring theme. So I've talked to a lot of people about this, both teachers and professional trainers in the C++ community, friends of mine, and I have gathered some rough estimates. Generally, in workshops for companies, some trainers claim that between 50 and 17% of attendees have their camera on. So always trainers ask for camera on. This is most of the time. I haven't met a trainer or teacher that doesn't ask for camera on, at least not in my case. So 50 to 70% of attendees have camera on in workshops for companies. This is when a trainer is brought to do a training in a company. In open workshops that are paid, camera on drops between 20 and 50% from what I've talked to people. These might be, for example, workshops at conferences and so on. Sadly, in uni courses and seminars, my teacher friends and myself, we've seen a way lower percentage. Roughly 10% of students have their camera on. And this is difficult. Like I told you, not being able to see their reactions, not being able to see their faces and their approval and their doubts in their eyes. It's really difficult for us to make a good job in teaching and reaching them and making sure we insist on the parts that we need to insist on. So beyond 21, hoping to be different. Going back to the theme of using C++ in CS1 and as a first tool to teach programming in general and programming concepts, is using C++ a lost cause? I think not. I've gained confidence over the years that modern C++ is simpler and safer, truly. And we have numerous opportunities to make it more teachable at the same time. By this, I mean both advances in the language and libraries in terms of what we standardize and the practices that we teach. Teaching good principles and teaching by real examples rather than fake textbook examples, showing real code, showing real bugs and real messy code, and trying to refactor code with students and show them better ways, teaching them to identify code smells, even in modern constructs, and teach them some caution, why not, in adopting all the new whiz-bang features from C++ 23 or something. Just because something is new is not necessarily great to be used everywhere. So we have numerous opportunities to improve as teachers and improve the language and the community as a whole, and the tools that we have are at our disposals to use for learning programming. You can get involved. There's actually a study group, SG20, in the ISO C++ committee that is dedicated to education. So I do encourage you to watch this wonderful presentation by Chris, How to Teach C++ and Influence a Generation. I think it's a very appropriate title and a very enlightening presentation. So I do have this link here. Again, bookmark it if you want to watch it later. So the king is dead. Long live the king, C++. I'm hoping that you'll reach out, and we'll continue this as a conversation in